Section 5. Using native assets. Now create a new asset and send it between nodes. On the first server, get the address that has the permission to create assets by typing this permissions issue. Create a new asset on this node with 1000 units where each is subdivided into 100 parts sending to itself. On the first server, execute the command which the address the user obtained previously. On both servers, verify name asset1 is listed. Type list assets. Check asset balances on both servers with the command below, get total balances. Here the user will see that the second server does not have any asset1 as shown. On the first server, send 100 units of the asset to the second server's wallet. The address here is the address of the second server found back in section 3, connection to a blockchain. Type in the highlighted command. As you can see, the transaction fails due to second server not having received permission as shown. To get the transaction to work, add send and receive permissions. On the first server, execute this command using a second server's address. The permission is hence granted as shown. Attempt to send the asset again. Execute this command on the first server using a second server's address. Note error messages should appear. Also note, give the transaction at least 1 minute for confirmation, otherwise the user will see another error message. On both servers, execute command to check their asset balances by typing get total balances. As shown, 900 units of asset 1 was left for the first server and second server has gained 100 units of asset 1. Execute this command on both servers to see most recent transaction. Type this wallet transactions 1. As shown, 100 units of asset 1 has been deducted from first server and second server has gained 100 units of asset 1. Section 6. Transaction metadata. Execute the following command on first server. Enter help send with metadata. Metadata can be included in a transaction. However, it must be in hexadecimal format as shown. Send 125 units of asset 1 along with metadata called deadbeef. On first server, execute the following command using address of second server. The transaction succeeds and returns the transaction ID as shown. To examine transaction, execute the following command on second server using that transaction ID. And you should get information saying that showing the information of the transaction. Section 7. Atomic exchange transactions. Now attempt to create a second asset and build an exchange transaction which swaps some of the first asset for some of the second. This transaction will be atomic, meaning that the two-way exchange must succeed or fail as a whole, also known as delivery versus payment. Create the second asset with 10 indivisible units On the first server, execute the following command using the address in section 5 using native assets. Check the assets on the first server by typing list assets. Now we will need to swap 50 units of asset 1 for 1 unit of asset 2. To do this, begin with building the exchange transaction on the first server, then complete it on the second server. Create a log transaction output containing 1 unit of asset 2 on first server. Here you have to note down the TXID and vout value. Because it is locked, this transaction output will be protected against spending unless explicitly spent or unlocked. Execute the following command on the first server with the TXID obtained previously. This will output a large hexadecimal block of text that contains the raw transaction data representing the offer of exchange. Copy this block from the first server, then on the second server, run decoder raw exchange and paste the block. The output will show you exactly what is represented by this exchange offer in the offer and ask sections. Create a log transaction output containing 50 units of asset 1 on second server. Type prepare log unspent asset 1 50. Also, note down the TXID and vout value. Execute the command on the second server using the hex block, TXID and vout values previously. This final hex block is a raw transaction representing the completed exchange. Execute the following command on second server to send transaction to the network. Send raw transaction and paste the hex block. This contains the regular transaction ID at the bottom of the hex block. Verify that the exchange is successful. Execute the following command on the first server. Get total balances 0. You may execute the same command on the second server as well. The last exchange of assets was performed automatically in a single transaction, viewable on either server using this wallet transactions 1. Section 8. Round Robin Mining. This section will start collaborative mining between the nodes. To do that, second server will be given permission to mine. On the first server, execute this command, using the address of second server from the section 3, connection to a blockchain. Execute the following command on second server to see how many permitted miners there are, by typing list permissions mine. Wait for a couple of minutes for blocks to be mined, and then, on either server, check the current block height with the command getinfo. You can see that on the first server, I have a total number of 433 blocks mined, and on the second server, I have a total number of 434 blocks mined. Get the hashes of the last few blocks. For example, get block hash 433, get block hash 432, get block hash 421. Finally, you should be able to get the block by typing the hashes of the block, and it will show you the information of the block.